Welcome everyone. Today we're going to be going through getting started with Kubernetes. My name is Denise Shannon. I'm joined here today with Josh Curl. Josh, do you want to say hi?
Yeah, sure. Hey, everyone.
So today's objectives, we're going to do a technical introduction to Kubernetes using Rancher. I have just a couple more slides just to do the introduction. I will be doing a demo of how to get Kubernetes up and running in Rancher, and then I'll be handing it off to Josh, and he'll be doing some demos of some Kubernetes concepts and how those work and show up in Rancher. So for the purpose of this training, we're assuming you understand basic Docker concepts. We also kind of assume that you have maybe seen Rancher or played around with it. If not, like there's a lot of parts of Rancher that we won't be covering in this training. The training team does an introduction to Rancher training once a month as well. The next session is Thursday, October 12th. If you go on this link here, you can go and sign up for it. A couple of resources. So we have a pretty thorough doc site, docs.rancher.com. This specific URL brings you to the Kubernetes section. We also have forums. So if you log into our forums, you can ask questions. The community is pretty active. I'll respond to you. So some key topics for today. As I said, I will be going through setting up Rancher, deploying Kubernetes, talk about setting up kube control. I'll probably hand it off to Josh then, and he'll be talking about pause deployment, services, config maps, and ingresses. So sometimes a lot of people ask, like, Rancher and Kubernetes, like, why would you do it? It's just better together. So I don't know if you've ever tried to set up Kubernetes yourself. It might be a little difficult to get up and running. For Rancher, we make a really easy and nice interface to be able to use. You can actually manage across different cloud providers using different nodes or hosts. And then one of the big features, I think, is like we basically automate your upgrade process. So with Rancher, you'll kind of see it where if we make a new release of Rancher and it has an updated version of Kubernetes, after you upgrade Rancher, you can just upgrade to the latest version of Kubernetes with one click. So let me get out of the slides. Let me get into. Okay, so what I've done today so far is I started up Rancher on a box itself. This is what you will first log into. You'll see you're brought into something called a default environment. This environment is actually what we call, it uses our cattle orchestration. And so the first thing we want to do is we actually would want to add a Kubernetes environment. So here I'd click on Add Environment, and you can select a Kubernetes environment template. I'm actually going to go back real quick. And go to add template. So sorry, not add template. Apologies. So here, when you start up Rancher, we have a couple default environment templates. These are just the different orchestrators. By default, it picks all the default options that we set before. So for Kubernetes, if you have different options that you want to take care of, you would click on Edit for that template itself. Under the Kubernetes orchestration, you can see that there's an Edit Config button. You can edit the configuration, select what version you want to use, and then here there's actually a bunch of different options available for you in terms of how you want to set up your Kubernetes setup. So I'm going to actually launch the docs itself as well. So it talks about what we've kind of gone through here about configuring Kubernetes, how to create a Kubernetes environment. So there are different options here, like plain isolation. So by default, we actually turn it off. So if you're like a developer and you're just playing around with it, that's kind of the default option you want to go to. Otherwise, if you're in production,
Yeah, I don't think your screen's been shared.
Oh, I'm so sorry. Okay, well, let's see.
Sorry,
Sorry, everyone. That was, sorry about that. Okay, so I'll go quickly through the slides again. I probably won't talk about us. Let's see. Here is the link. We'll do a high level. Here is the link of if you want to do an intro to Rancher training. It's just rancher.com/training. The doc site is, you can either go to docs.rancher.com or rancher.com/docs. Our forums is forums.rancher.com. And then key topics. So let's go back to, I'm going to start from the beginning here so you guys can actually see what's going on in Rancher itself. Oops. So all I've done is set up a box. All I've done is start and run a Rancher container. How to start and launch a Rancher container is installing the Rancher server. I've just done the most basic use case here, or a vanilla Rancher. There's a lot of options in terms of how you can start Rancher server. I'm not going to cover those today. That would be in the other training session that we lead once a month. Once you come into Rancher, as I said before, you usually, I just realized that I actually started the wrong version of Rancher. As I look at the bottom here, the version here is 1.5.10, where I actually want 1.6.10. So I'm going to SSH into my box. You can see I'm currently running it. I'm going to stop it. I'm going to restart it. And I'm just going to actually pick, I'm not going to put a version in and let it pick the latest one. Okay. So now if you want, you can follow the logs. It usually takes 1 or 2 minutes maybe for it to load up as it goes on. Sorry about that, everyone. Let's see, starting up. Go here. We'll wait for it to load. Okay, it's up and running. So when you first come in, this is the page you will see. It asks if you'll let us collect some stats. I actually uncheck it because I obviously work here, but I encourage you to let it click on the stats because those allow us to just gather information more about what kind of environments are you using. Are you using cattle orchestration? Are you using Kubernetes? Also usually what Docker version you're running or what type of OSs you're running, just so that we can make sure that the most popular distributions and combinations are being tested. We obviously can't test all combinations, so we try and get the most popular ones. So as I said before, the first thing you do is you come in here. I'm actually just going to turn on what we call access control authentication, just so no one can come into my demo and mess around with it. I'll turn it on. I will actually add Josh as a user so that when he starts to do his part, he will be able to log in as well. Now I'm going to go into my manage environment. So this is what I was talking about before. So when you come in, there are a set of default environments. Here you can edit these. You would want to change and edit the Kubernetes one. Go into the Kubernetes section for orchestration, edit the configuration. And here you can see the different configuration options that exist. So as I was describing before, there is plane isolation. So if you're in production, you would want to isolate your data orchestration in compute planes. So the data one is where etcd is running. Orchestration is all the containers and services that Rancher spins up to get Kubernetes up and running. And the compute planes would be once Kubernetes is up and running, once you start adding containers, which host those containers go to. There's a couple other options here about Kubernetes RBAC. In the latest versions. You can turn on Kubernetes RBAC. You can manage your namespaces within Kubernetes using RBAC. If you're behind a firewall, you can set what your private registry is. There's, let's see, these are the more popular options that I'm covering. By default, we have our own ingress controller. What that does is if you created ingress, it will use Rancher's load balancer, which is running HA proxy, to be able to start servicing your containers. You can turn this off, and then I know a lot of people like to use the Nginx ingress controller. So here, when you configure Kubernetes, if you know that's the ingress controller you want to use, you would want to put this as false. By default, we run the add-ons for Dashboard, Helm, SkyDNS, and other ones. I would not recommend turning this off, but it is an option for you. And then a lot of these other ones in the bottom are more about for backup and FTD. So I'm going to just say configure that. I'm going to save my template. And here I'm now going to add my environment, and I'm going to make a Kubernetes environment. I'm going to pick that template that you just configured so it has the Kubernetes options that you want. I'm going to add Josh as a user here so that he can also see the environment when he logs in, and I'm going to create this. I'm going to switch to this environment. By default, the first thing you'll see is that when you first get in, it'll say, like, basically you're waiting to add some hosts. So here, you're going to go to the infrastructure host page. You're going to add hosts. So the host options that you have out there are being able to launch a custom command on any host that you've already spun up. You could also use the options to be able to start anything that we have through our UI, and they just run Docker machine commands to start up some hosts in these cloud providers. We cover that in more details in the other training. So for here, in today's speed up the demo, I'm going to actually copy these two ones that I already have open. I have 3 boxes here that all I've done is pre-pull the images that I needed for today's demo, just so we won't be spending time wasting and waiting for these images to be pulled. I'm going to add these as hosts. You'll see them immediately pop up because the Rancher agent container starts. And then because we have Kubernetes, it starts launching, all the infrastructure stacks that we need to get Kubernetes running. So I'm going to, while I wait, go to the infrastructure stacks page. You'll see we run a health check, IPsec, network services, and Kubernetes. So these health check, IPsec, and network services, that's what Rancher needs to run in order to get your setup, kind of your overlay network going on. It just is what Rancher does for containers and setting up the actual Kubernetes cluster itself. Here you can see everything looks like in our Kubernetes stack is up and running in green. I'm just going to do a couple of things. Here you have the option to go to our CLI. We provide one here. Before I go and try and okay, everything is up and running. I was just checking that our add-ons are starting. Sometimes they take a little bit to start up. Once they're up and running, you can go to click on the dashboard and click on the dashboard link. See the dashboard. This is all up and running. And so at this point, I'm going to hand it over to Josh, where he will continue to talk about the rest of the Kubernetes concepts and demo them in Rancher.
Chris, ready? Am I presenting?
Yes, I see your slide.
Okay. So from here on out, all the concepts that I'm going to be discussing are purely Kubernetes concepts. So if you were to use some other Kubernetes cluster, like the same things would apply there as they would in clusters created and managed by Rancher. So the first thing I'm going to discuss is the idea of pods. So a lot of people, when they go into Kubernetes, they get a little bit confused. They can't just go and launch containers. So knowledge of pods is kind of necessary to understand like one of the more fundamental things in Kubernetes. So these are the smallest unit that you can actually deploy to Kubernetes. So they're a group of containers that are tightly coupled. So these containers will always run on the same hosts, and they're also going to run in the same network namespace, which means that two containers within the pods can talk to each other via localhost. And for the purposes of this talk, I'm only going to launch pods that contain a single container, which are really the most common use case for them. So if pods seem like a confusing idea to you now, just hold off, and then they might get more use out of them as you get more familiar with Kubernetes. Okay, so now I'm going to switch back to my Rancher environment and refresh. Log in. So what I'm going to do is set up the CLI so that I can. Oh, can you give me access?
To what?
Oh, am I not the owner of this environment?
You are, but I did not turn on RBAC.
Okay, that's fine. Okay. All right, so I'm going to place this file in .kube-config, and then this will just give me access to this Kubernetes cluster from Rancher. So what we're going to do is just type kube-control get nodes just to show that we're actually connected to the cluster. Cool, looks like we are. So on the left, I'm going to go over to the host page just so that we can see some of the containers coming up on the left as I launch them soon. All right, so the first thing I'm going to do is take a look at this YAML file, which is representing a Kubernetes resource. So as you can see here, this is in YAML file format, and there's a lot of fields in here which are going to be universal to all resources that you launch in Kubernetes. So the kind here is pod, the version is v1, and we're going to have a metadata with name of nginx. And then under the spec here, which defines which containers are inside this pod, we can see that we have one that's just using the Docker nginx image, and then we're going to expose it on port 80 just to internal traffic. So now to launch this pod, I'm going to use the kube-control create command, and then pass in this resource file to -f flag. So now we can see that the pod was created, and we can see on the left here that the container was brought up and showed in Rancher. So the next thing I'm going to do is grab the IP address of this pod so we can use that for the next part of the demo. So to do that, I'm going to use the kube-control describe command. So I'm going to do kube-control describe pod nginx. And here we can see that the IP address, which is only accessible for other pods within the cluster. So the next thing I'm going to do is launch another pod that is just going to contain a simple shell that we're going to use to exec into later to have like a view from inside the cluster. So I'm going to do kube-control create again to create this pod. And then I'm going to exec into this with the kube-control exec command. Okay, so now what I'm going to do is I'm going to curl the IP address that I grabbed earlier. And we can see that we're actually hitting the nginx pod. So whenever you use Rancher, we are going to set up networking for you, and this includes the Rancher IPsec network. So all traffic between pods is fully encrypted. All right, so the next thing I'm going to show is just a resource from Kubernetes that has a little bit more information going on here. So whenever you launch pods, there's a lot of other configurations available that you might typically see whenever you use the Docker run command. So these are things such as setting environment variables or binding files in from the host. So for this example, I just added a simple environment variable here, and then a bind mapped from the host, and then just a couple other rules that you can set on pods. All right, so now we've launched a few pods, I'm going to discuss the idea of deployments. So whenever you launch a pod, this is actually something that's pretty ephemeral within Kubernetes. So when a pod gets launched, it gets bound to a node and then run on that node. But if for whatever reason that pod was deleted or that host went down, Kubernetes will not actually reschedule that pod onto another host. So to manage the lifecycle of pods, we can use something called deployments, which are a level of abstraction above pods. So these define how you want a particular group of pods to look and the desired scale of those pods. So this is generally what you would use to interact with pods or with Kubernetes rather than pods directly. If any of you have seen other Kubernetes tutorial online, you might have seen the concept of replication sets or replication controllers. But I would say if you're new to Kubernetes, just focus on deployments instead. These are like generally where most user computes resources are headed. There might be a specific use case for using one of the older ones, but in general, I think I would just use deployments. Okay, so the first thing I'm going to launch is just a simple Nginx deployment, which is basically the same as the pod we launched earlier, except that we're going to set the desired number of replicas to 3. And then under the template metadata, we're going to set each pod to have a label of app Nginx. And this is something we'll come back to later on in the demo. So again, I'm going to use kubectl create to create this deployment. And then if we do kubectl get deployments, we should see this newly created resource show up. And now if we do kubectl get pod, we can see all the instances of the pod managed by the deployments coming up. Okay, so the next thing I'm going to do is use the kubectl scale command to modify the current scale of this deployment. So to do this, we'll use kubectl scale and set the deployment to Nginx. And I'm going to turn down the replicas to 2. Now if I do kubectl get pod, I should see that one of these is terminating, and then after a second or so, we'll see that we only have 2 instances of this running. The next command I'm going to show is kubectl edit, which will just take a look at one of the resources we've launched within Kubernetes, and then allow us to edit some of the fields on it. So I'm going to type kubectl edit deployments Nginx. And then we can see here, this is very similar to what we actually saw in the resource file earlier, but this is actually the internal representation of it. So once you do kubectl create, Kubernetes is actually going to store that resource, and then the current state of it is actually what you're seeing here. So you see we have replicas 2 instead of 3, but we can change it back to 3. And then once we exit, we can see that it was updated. So now if we do kubectl get pod again, you can see that we have 3 instances of Nginx back. Okay, so the next command I'm going to show is kubectl apply. So this is very similar to kubectl create, but if a resource already exists within Kubernetes, it'll update it rather than trying to create it again. So let's take a look at the resource file again. So you can see that we're on image version 1.13. So let's say for some reason we wanted to downgrade to version 1.12. So I'm going to modify that, and I'm going to do kubectl apply. And we can see that it was configured with the new image. And then just to show that like what Kubernetes has internally is correct, I'm going to use the kubectl gets command. Except this time I'm going to use the -o flag to export it as YAML. So this is basically the same YAML that we saw earlier when we used kubectl edit, but this time it's just printed to the terminal. And we can see that Kubernetes now has 1.12 stored internally. And if we do the same thing for the pods to make sure that the actual pods are the right version, so kubectl get pod. I'm just choosing one instance randomly here. We can see that this actually has version 1.12 as well. So you can think of kubectl apply as a command that just says update the resource if it already exists and otherwise create the resource. So generally, once you are familiar with kubectl apply, you can use that instead of kubectl create. All right, so the last thing I'm going to do is just show off another command, which is kubectl run. And this allows you to create a deployment from the command line without having a resource file existing already. So I'm just going to create another Nginx deployment. And let's give it replicas of 2. And if we do kubectl get deployments, we can see that it's created. Okay, so the next topic I'm going to discuss is that of services. So now that we have a bunch of pods that are managed by deployments running in our cluster, we need some way to expose these to other deployments and pods running within the cluster. So rather than having to maintain some kind of system of tracking all the different IP addresses of the pods, something we can use within Kubernetes is that of services. So this allows you to define a DNS entry that you can use to refer to other pods within the cluster. So these are pretty similar to the functionality you would get with load balancers. So it just gives you a consistent endpoint that you can use to refer to other pods in the cluster. Okay, so for this service here, we're going to give it the name of Nginx, which we'll see later actually defines how the DNS entry is actually created. We're going to say selector app Nginx. And so what this says is route traffic to any pod that has the label app Nginx. And you remember earlier when we launched the deployment, we actually added this label onto it. So the deployment itself is responsible for attaching this label to any pod that it manages. And then we're going to say that we're going to route traffic from port 8080 to 80, and also traffic from port 80 to 80. So I'm going to create this service with kubectl apply, and then use kubectl get service just to make sure that it was created. Okay, we do see the Nginx here. So now I'm going to go back and I'm going to exec into the shell command that I launched earlier. So now the first thing I'm going to try doing is just doing a curl on this cluster IP. And we can see that traffic was routed to one of the Nginx pods. So we're not actually sure which one it was routed to, but in this particular case, it doesn't really matter. And so now that we know the cluster IP is working, so the next thing I'm going to do is try curling the DNS entry. So now I'm going to do curl Nginx, which came from the name of the service, and then .default, which came from the namespace that we're in. So we didn't really discuss namespaces in this tutorial, but they're just a way of grouping various resources within Kubernetes. In this case, it just defines or it affects the name of the DNS entry. And the rest of it is .service, .cluster, .local. And we can see they get the same thing here. So the DNS entry will resolve to the cluster IP, which will then route traffic to one of the pods. So let's also try it on port 8080, since this should also be routing traffic to port 80. And we got the same thing here. So now that we've discussed services, the next concept I'm going to discuss is that of config maps. So this allows you to create files within Kubernetes and then expose these to pods within your cluster. So this is useful for images that may have some dynamic configuration, such as Nginx. And you can also expose these as either environment variables within the pod or as local storage mounted within the pod. So if you've ever seen the Nginx image, you can see here that they recommend.
Sorry, don't mean to interrupt.
Question?
Yeah, so there's a question. I think you're just covering services. Oh, someone asked, is it a record with multiple IPs? Could you show the results of dig? I don't know.
Yeah, dig will just give you the cluster IP. So there is configuration available for services to just route to the underlying pod IPs and just do round robin DNS. But the default is to return the cluster IP, which is then responsible for routing traffic.
And then someone else had asked if the YAML files that we're doing in our demo are available. Yes, they are available. I'm going to go see if I can poke around to figure it out, and I'll post it in the answer for this question.
Cool. Sounds good. Okay, so for this image, you can see that you can do a by mount in of the Nginx configuration just to whenever you're doing Docker run locally. But whenever you're running in a clustered environment, this doesn't really work because you're not sure which host this pod is going to land on, and you're not sure if this configuration is going to be available on the host. So to do something like this, you can actually create the configuration file and store that within Kubernetes, and then do it all from within Kubernetes. So to show that, the first thing I'm going to do is create this resource that represents the config map. So what we're storing here within Kubernetes is just a simple map of keys. So we're going to store key 1, which has value 1, and key 2 with value 2. I'm going to use kubectl apply to create this. Then I'm going to do kubectl get config map test CM, just to see that we actually have the contents of this stored within Kubernetes now. So we can see here our two keys that we launched earlier are actually stored within Kubernetes itself. So now that this is created within Kubernetes, we can actually expose this to pods. So first I'm going to expose it as environment variables. So you can see here, I'm just creating a simple Ubuntu container that just sleeps forever. Then under the environment section, what we're going to do is reference the existing config map and set some keys. So we're going to set primary key equal to the value of key 1, and secondary key equal to the value of key 2 from this config map. So I'm going to use kubectl apply to create this pod. And I'm going to exec into the container just to show that these are actually set properly. So it might be still coming up. Yeah, I think it was just taking a second to pull the image. Okay, so if I type env now, just to show what environment variables are currently here, we can see that secondary key is set to value 2 and primary key is set to value 1. So the other method we can do is we can expose this as local storage within the pod. So you can see here it's the same container otherwise. What we're going to do is we're going to mount in a volume into etc config, and this is just going to be sourced from the test config map. So I'll create this with kubectl apply again, and then exec into this. So now if I go to the etc config directory, we can see that there are two files here. There are key 1 and value, or key 2, and then the contents of these files are just going to be the corresponding contents of the config map. We can see it's value 1 and value 2. So the next concept I'm going to show is that of an ingress. So now that we have some services running within our cluster, the next logical question is, how do I expose traffic outside of the cluster? So the best way to do this is using an ingress resource. So let me show you a simple YAML file here. And if you notice, there's these 3 dashes here that separate the file, and then there's one resource here and one resource here. So this is kind of like a general feature of YAML and Kubernetes where you can put multiple resources within the same file. So in this case, I'm just going to have 2 ingress resources in the ingress.yaml file. So we're going to give the first ingress resource the name of proxy, and we're going to bind this to the HTTP port of 9000. So what this is actually going to do once we launch it is spin up a Rancher load balancer, which will meet the specifications we define here in the ingress resource. So what we're going to do is route traffic to the proxy backend on port 80. And then for this second one here, we're going to bind to port 9001 and bind to port 80.
I mean, I think this is a common question when you start to use Kubernetes, but someone wants to further explain the difference between ingress and load balancer, or how the relationship between the two.
Yeah, that is a good question. So ingress is generally more powerful than using a service with type load balancer. So service with type load balancer really just takes the public IP created by the underlying cloud provider. So if you're running on AWS and you create a service with type load balancer, it's going to give you an ELB load balancer, which just gives you a public IP address to route traffic to something within the cluster. Ingress resources allow you to define more complex routing rules, which I'll show in a little bit. First, actually, I want to take a step back because I forgot to launch something that I was going to launch, but I usually launch before ingress. And it's just another example of using config maps for deployments. So in this case, I have an Nginx configuration called defaults that just sets up a proxy to rancher.com. So what I'm going to do is I'm going to create, I'm going to turn this file into a config map within Kubernetes without using a resource file. So if you use the kubectl create command, and then you give it the config map parameter, and then I pointed it to the configuration that I just showed, it actually created a config map for me and then stuck this file in it as a content. So now I'm going to do kubectl get config map just to show the contents here. we can see that Kubernetes is actually storing an Nginx configuration now. And so the next thing I'm going to do is launch a deployment that makes use of this configuration that we just created. And so I'm going to mount this into the folder etc nginx conf.d. And this is just the default directory that Nginx will look for whenever it starts up. So I'm going to create the deployment with kubectl. And then I'm also going to create a corresponding service so that others within the cluster can see this. So I'm going to give it the name proxy. It's going to look for the selector app proxy, which was set on the deployment. And then it's going to route traffic from port 80 to 80. Okay, so now the proxy was created, the deployment was created. So if I exec into my shell again, I should be able to do a curl of proxy.defaults.service.cluster.local. And we can see here that what we're getting is actually the rancher.com website. So now that that's launched, I'm going to go back to discussing ingresses. So the first ingress here is actually going to be exposing this proxy service to the outside world, and the second one is going to be exposing the Nginx resource which we created earlier in the talk. So I'm going to do kubectl apply to create the two resources within this file. We can see that there are actually two created here instead of one. So now that those are created, we can see within Rancher, there are load balancers starting to be spin up on these hosts. So now if I do kubectl get ingress, it will show me all of the available ingress resources. And once these are available, it will show which host these are available on. Or it should. Well, we can see the proxy load balancer is coming up on this host here. So if I just go to the IP address of this host and then go to 9000, which was defined to listen on, we can actually see the rancher.com website exposed outside the cluster. And likewise, we see the Nginx load balancer running on this host. And then if we go here, we should also see we bound to support 9001. We'll just see a simple Nginx page. So these two ingress resources which we launched here are two pretty simple ones, but there's also options to route things based on like the host name that you pass in and other things like the path to. So we could have like path 1 or path 2 route to different containers or pods within the cluster. Yeah, it looks like it's a little while for these addresses to update, but it will show you which actual hosts these land on. And so I think that's all I have to show. Are there any questions?
No. The questions that came up, I asked you directly. I mean, I think that's more or less what we have to show for today, unless anyone has anything specific. I don't know if you still have, since you're sharing, do you still have your slides up? The only other site that I wanted to go through was we are on Slack. If you go to slack.rancher.io, that's our user Slack. We have a Kubernetes channel there. It's pretty active. If you have questions about, when you're getting set up, if you face some issues, or if you're trying to set something up, you can go there. So please join us there. It looks like someone did ask, how does Helm integrate with Rancher Kubernetes?
So we have Helm deploy out of the box by Kubernetes, and it's available in a web UI within Rancher. But that's just like the CLI for now. In the future, we plan to integrate Helm templates more with our existing catalogs that you can launch Helm charts through there and manage the lifecycle through Rancher. But right now, it's more of a CLI-based experience.
When we use plane isolation, do you know where I think probably the add-ons usually go? Do they go on the orchestration plane?
I don't
or the
think
compute plane?
I don't think we actually define any rules for those. Yeah, I don't think we define any rules for the add-ons currently.
All right, so it sounds like for that one, it could land on any of them then?
Yeah, but those are managed by Kubernetes, so those could be moved around between hosts if there's any like error where they are down or something.
Yep, since Kubernetes does the scheduling of it, they would reschedule it if there's any issues with your host.
And the only one that needs to be really thought about for HA is probably Kubernetes, which we do run mobile replicas of. They can be configured through the catalog with launching Kubernetes.
Okay, someone followed up for the Helm one is, can you use Helm to deploy node selectors?
A node selector is an attribute of a pod. So you would put that on a deployment if you wanted to, for example, like isolate where those pods were launched to within the cluster. So you could go and you could label particular hosts with a given label, and then when you launch the pods, put a node selector on them. But yeah, I guess you could launch them within pods, but they're not like a top-level resource or anything like that.
Let's see. So someone asked, can you choose the Kubernetes version to be installed through Rancher? So I can answer that one. So for Kubernetes, obviously there's lots of versions of Kubernetes, and because we are packaging and maintaining it, usually you can select what version. We have basically selected and verified and tested out with whatever Rancher version there is. It is usually about a one-to-one mapping in terms of Kubernetes version, but we do try and keep up to date as much as possible. For example, currently, if you launch the latest Rancher, I think we're running 1.7.4. We are in the process of testing out Kubernetes like 1.8, the beta versions, because that's to be released at the end of the month, so that when Kubernetes 1.8 comes out, we are able to also support that in Rancher as soon as possible. So that's usually how you can pick which versions are available. Another one asks, what's the, I guess, best way to start Rancher for learning and practicing? That's really, you could, on YouTube, most of our training videos that we've produced are out there. You could follow along, at least how to start up Rancher. As I said, this training is Kubernetes focused. The other one is really all about Rancher, starting, setting it up, all your options there. So you can look for that and follow along with there. Someone asked for Kubernetes, will there be an upgrade path? So yes, usually for any versions of Kubernetes, you go from one to the other, as long as Kubernetes itself has a fairly, I think there have been, in much earlier versions of Kubernetes, there were some weird quirks about when you upgraded between their versions, but as long as if their versions are going to upgrade successfully, we usually support that as well, so it won't be a destructive upgrade. I think those are at least all the questions that I had come in for now. There's one more of, how can I get Prometheus into the Kubernetes cluster?
I would say using Helm would probably be the best way. There is a Helm chart available, and that allows you to manage the lifecycle a little bit easier with some pre-configured options and stuff. We don't have any built-in first-class integration with Prometheus quite yet.
Yeah, so there's going to be a difference, I think, between, so what Josh was saying is, okay, sorry, the question is, it's in the community GitHub, but it's not in the ad catalog. So most of the community GitHub entries are for, or community catalog are actually for our cattle deployments. So basically, if you're not using Kubernetes and you're using our own orchestrator to do that, if what Josh said is that there is a Helm chart available for Prometheus, so you could, I think, just run, we already start, is it Tiller and Helm?
Yeah, Tiller and Helm are available by default in Rancher, so you could just use the web UI and then install whatever Helm charts you want from there.
Yeah, so you could just do I think, it's Helm install, and then whatever the Prometheus chart is there. So Helm obviously has a bunch of charts available to the community themselves, so you can just install that directly using Helm. We currently don't have a direct integration with Rancher and Helm in terms of a nice UI, like how we coordinate with our catalog, but that is definitely something we're looking into. So it seems like the questions are slowing down. I'll probably turn off the audio. We'll hang out on the webinar for like a couple more minutes, and we can answer it through the question and answer part. But everyone, I just want to say thank you for joining. I really apologize for the beginning and not actually sharing my screen and showing our slides as we started. Hopefully we were able to recover and you were able to catch up what was going on. We do have our videos. These are recorded. They will be up online. The previous old ones are also up online as well. So if you have any questions or want to re-review it, please feel free to go there. I think it's on our YouTube channel. And everyone, hope you guys have a great day. Thanks.